Hi, thank you for viewing my presentation. My name is Buffa and I will be presenting my project proposal dealing with climate change adaptation through appropriate technology. The project is based on the premise that informal settlements in developing cities are especially vulnerable to climate change due to infrastructural and socio-economic deficits. Furthermore, large-scale formal urbanism reproduces patterns of inequality which exacerbate this vulnerability. In response, the development of a new conception of urbanism is pertinent, one which emphasizes cooperative and reciprocal development between the formal and informal sectors. The proposal seeks to address climate change adaptation through the development of appropriate construction technologies. The approach is aligned with O'Brien and O'Keefe's definition of climate change adaptation as the adjustment of the built environment to be more resilient to current and projected climate change exposures. Emphasis is placed on using a participatory approach in order to assure community agency and ownership. Informal settlement is becoming prevalent in Tshwane as marginalized groups seek urban inclusion. These settlements take on different forms and scales, but share similar vulnerabilities to climate change. Rapid growth can be observed in Tshwane's informal settlements since 2008. This trend increased exponentially from 2015, highlighting the importance of climate change adaptation to reduce the current and future vulnerability of this rapidly emerging urban group. For the purposes of this project, the focus will be on Malusi, an informal settlement to the northwest of Pretoria's CBD. Malusi is a developing neighborhood established in 2008. While there are signs of formalization and formal construction techniques in the settlement, the available information seems to indicate that many dwellings utilize the same informal techniques present in similar settlements. This takes the form of timber frame structures clad with recycled panels of timber or metal. These techniques are important to consider when proposing future developments in Malusi. With a basic understanding of the context, vulnerability mapping was conducted to better understand the current and future conditions in Malusi, which could result in climate change vulnerability. Climate change impacts can be seen as a result of exposure to climate change hazards and an entity's sensitivity to that exposure. The adaptive capacity of the entity determines its overall vulnerability to these impacts. Three main climate change hazards were identified in Malusi, namely rainfall variability, increased temperatures and heatwave days, and increased frequency and severity of extreme weather events. Exposure to these hazards is significantly increased by the existing infrastructural and socio-economic deficits present in Malusi. For example, Malusi's prevalent construction technologies increase the exposure of vulnerable population groups to hazards such as increased temperatures and extreme weather events. Furthermore, residents' limited access to healthcare services and information exacerbates this existing sensitivity and reduces the settlement's adaptive capacity. At a human scale, these sensitivities may have several negative effects. For example, a pregnant person may experience health issues from exposure to high temperatures. This hazard may also reduce the effectiveness of the current health post, leading to further negative impacts for the residents. Following the vulnerability investigation, the identified sensitivities in Malusi were mapped, allowing the projection of possible impacts resulting from the exposure to climate change hazards. Additionally, adaptive sensitivities or leverage points were identified. These issues could be addressed to reduce climate change impacts within Malusi and thus reduce its overall vulnerability. Based on the vulnerability mapping, education, access to information, access to healthcare services, social support, and construction technology were identified as important leverage points to address. This helped form the foundation of the conceptual premise. Using the identified leverage points and the requirements of the COPC brief, a list of programs was generated to guide the intervention. A spiritual space, community center, research center and clinic, market space, temporary housing, and workshop will be used to address both the client brief and leverage points. The projected users of each space were also mapped to help inform the eventual design. The site of the intervention is in the southeast of Malusi between two phases of the settlement. This is the location of the existing COPC health post as well as educational and youth facilities. Due to the relatively small scale of the intervention, it was important to consider the different levels at which it operates. This includes its spatial response to the immediate context, systemic response to Malusi as a whole, and the potential lessons to be applied within other informal settlements in the Greater Tshwane area. Due to the complex nature of Malusi, the intervention considers several key factors. Firstly, the idea that informal settlements are complex urban structures which are sustained by both informal and formal systems. This necessitates the development of an urbanism which considers the needs of formal and informal actors. Secondly, regenerative development is important to ensure that solutions initiate processes which can develop and evolve over time. Finally, it is imperative that solutions are technologically appropriate and recognize existing skills, materials, and techniques in order to ensure continued development and provide the community with agency and authorship. The spatial articulation of the intervention should therefore consider layering of formal and informal processes, incremental reciprocal development, and the use of available skills and technologies. Based on these strategies, preliminary spatial principles were projected. These deal with the layering of space and technologies, considering static, dynamic, and transient relationships to ensure flexibility and accommodation of informal technologies and processes. These explorations allowed the generation of a preliminary design response. This began with a site analysis which considered physical features and boundaries, nodes, negative spaces and important edges, social and systemic exchanges, and programmatic and systemic links. This was used to generate an initial mass exploration on the site of the existing health post, responding to a contextual grid and other particularities of the context. This was then refined into a preliminary massing sketch. The massing was further developed using a layering approach. First, programmatic relationships were explored spatially. This allowed an indication of the spatial qualities required to house each combination of programs, which could be used to determine suitable construction materials and methodologies for each space. Spaces were then coded as static, dynamic, or transient in order to determine their overall spatial and technological articulation. Several iterations of massing were explored and refined into a sketch plan, which indicated the main programs as well as the static, dynamic, and transient coding of the intervention. The northern edge was identified as the main public interface, which initiated an exploration of public, semi-public, and private spaces to inform site ordering and access, and ultimately leading to the development of the intervention's urban edge. At this stage, the articulation of the systemic response became pertinent. This is layered according to the static, dynamic, and transient coding which informed the design thus far. Static spaces provide fixed programming, including the health post and research center. These spaces use standard masonry construction techniques and provide the permanent anchor points of the intervention. The static layer addresses leverage points and climate change adaptation through the provision of essential health and well-being services, education, and access to information. Dynamic spaces house flexible programs such as gathering and event spaces, providing social and spatial services to the public. These are articulated by additive or infill structures which use contextual materials, knowledge, and techniques from local experts in collaboration with external expertise. This reciprocal relationship between formal and informal actors is intended to develop new construction technologies which reduce exposure by using existing materials and expertise in new ways. Overall, the dynamic layer addresses adaptation by providing social services and, more importantly, the development of more resilient construction technologies to address infrastructural deficits. Finally, transient spaces are non-programmed, allowing the generation of emergent programs to suit the community's needs. The intention is for these spaces to serve as community-driven testing grounds for skill sharing and the refinement of adaptation technologies developed through the construction of the intervention. This would function in conjunction with a workshop where large-scale contextual adaptation technologies are further refined on a smaller scale. Modular elements such as solar screens or insulated roof overlays could be tested in temporary installations such as markets before being made available to individual households. Ultimately, this layer addresses adaptation through further technological development and the incremental in-situ upgrade of existing structures to reduce exposure to climate change hazards. In addition to their adaptation roles, the systemic layers interact spatially and programmatically. These links strengthen individual programs and allow flexibility in use where necessary. Technological interactions between layers are also important to consider and have structural and spatial implications. This is briefly highlighted by site sections through a combined static and dynamic space, related dynamic and transient spaces, and two static spaces. The intention is for the intervention to develop incrementally, beginning with a static shell, moving to the infill of static programs, and further development of dynamic spaces and contextual adaptation technologies to articulate additional functions. The ultimate goal is the development of a complex reciprocal intervention which recognizes the needs and values of both formal and informal urban processes to facilitate future community-driven development and climate change adaptation. To conclude, the intervention seeks to reduce climate change vulnerability in Malusi at several levels. The programmatic provision of essential health and social services addresses the leverage points of education, access to information, and access to healthcare. In addition, the incremental and reciprocal development of the intervention acts as a site of research and development. This allows the generation of appropriate contextual technologies and techniques to reduce exposure to climate change hazards. These responses will be further developed on a modular scale, allowing individual in-situ upgrading driven by Malusi's residents. Ultimately, it is hoped that this model could result in the development of appropriate technological solutions to climate change vulnerability, with the potential to be replicated in other informal settlements in Tshwane.